25,000 stores currently. And I'm responsible for solution architecture for the Dollar General app and web applications and the data architecture behind the scenes that powers Dollar General app and web. That's about me. Just a small disclaimer before we go in detail. Since Dollar General is a public company and the stock is available to trade in public, any views are represented in the presentation are just for representational purposes. It doesn't either positively or negatively impact the stock price. So just want to have the disclaimer before I start. So all right, let's talk about today's subject, which is cyber attacks in generative AI and agentic AI frameworks, specifically in retail domain. Retail domain being different than other domains, we would talk about how the cyber attacks impacts retail domain in general, and how to deal with those how to deal with those attacks on the retail domain. I'm all through this presentation, I'm going to talk about the business behind retail plus the technical concept. So if you have any doubts, always you can stop and ask the questions. I'd be happy to answer the questions. So let's go to the first slide, right? So retail industry in general, right? I think have started adopting generative AI technology of late, and artificial intelligence has moved far beyond traditional analytics and reporting, which we also do in Dollar General. I think we have moved far beyond just using artificial intelligence for just analytics and reports. So we are using, we started implementing generative AI and agentic AI models for day-to-day retail operations. Also, these are now being used to personalize customer experiences, automate decision making, like optimizing the prices for the customers, and also manage and few other operations, right? So for most of these retailers, these AI-driven capabilities are kind of becoming non-experimental, in the sense like they're becoming mission critical, and they're mostly in implementation phases to implement generative for all those features that I was explaining above. So what makes this transformation special, right, is the traditional retail apps like dollargeneral.com or Walmart or Amazon. It's mostly click driven, where user searches for products and then buys the products, all that. But of late, retailers have started implementing chat-based systems where you just update your or give the chat bot your list of products that you want to buy, and it would automatically search through your app and adds it to the carts, and then it takes you to the checkout page. If you have authorized the checkout, it would automatically check out using your card payment, all that, and it would place the order on your behalf, right? So these kind of features have becoming more and more common in retail applications, and generative AI has been being used widely. So with the use of generative AI, there exists security issues as well. Particularly, retail is a little different than other applications like banking, other sectors, because most of the retailers uses both guest accounts and authenticated user accounts. So for most of the retailers, at least retailers like our company, Dollar General, 50% of the traffic is driven by the guest user traffic, which is an anonymous user traffic. Um, they are not authenticated. We don't know who the user is. We don't know whether the user is a genuine user um, or a bot who is trying to scrape the data and trying to get some data through the website, right? So this poses a risk on the apps and webs which uses generative AI behind the scenes, because they can actually either poison the model, or or there are so many ways to attack the models and poison your models in such a way that they can bring your entire website down. So the motivation for this research is to identify at least some of the use cases and try to find solutions to mitigate the risks. Right? I'll move to the next slide. So, as you all know, again, Agentic AI refers to systems that can make decisions and take actions on its own, and it adjusts strategies autonomously to pursue some of the business goals that were given to the models. Right? In practical terms, Agentic AI shows up across both digital and physical channels. Um, when I say digital, it is online channel where AI agents manage customer conversations through chatbots and voice assistants. And then there are personalized home pages where AI agents autonomously create the personalized home pages for the customers, and also influence search rankings based on the customer um, purchase history. All that today is being driven by agentic AI. And in offline channels like omni channels, where agents can help decide like buy online, pick up in store kind of options, and then it can also help in the delivery routing. If there is a delivery option for the particular retailer, it can help chart out the routes for the deliveries when a customer orders a delivery order, and also store fulfillment prioritizations. All those are some of the examples that AI can help in the offline channels. So in large environments, agentic AI systems like rarely operate alone, right? They function as part of the, of a network of interconnected agents, wherein, for example, a customer engagement agent may influence a recommendation agent, right, which then feeds these insights into the pricing agents, which then the pricing agent, which it will adjust the discounts and so on and so forth. And it also affects the way inventory is planned, and how the stores are allocated, uh, or how the stores are fulfilled with the stock, all that, right? Um, so while these interconnected decision making improves efficiency and responsiveness, it also means that it opens up a channel for the attackers to attack the systems and then bring down the interconnected systems uh, by by attacking one agent. The agent subsequent agents that are interconnected will also get affected, right? The main issue over here in the retail domain is for companies like Dollar General, we battle uh, a situation called as data scraping. Data scraping is something like where um, simulated bots hit your product APIs. For example, product APIs are nothing but pages that displays product information. It has information like pricing, the store where the product is stored, and it also some crucial information about the product, the weight, the attributes, all that, right? So what these scrapers does is they make use of the guest APIs, and they constantly hit these product APIs with guest authentication, and they retrieve those pricing details. And if you have like 50,000 products in the company, they would, and you have 25,000 stores, you combine 50,000 with 20,000 stores, that would become around 2 billion hits to your app, right? So they would continuously hit 2 billion. There are ways on how to hit 2 billion requests, right? They normally don't typically do it with one server. There is something called as ASNs. They change the ASNs, and then for every so many requests, they change ASNs and hits continuously to retrieve all the prices in different stores. And then what this bad actor will do is they would sell this data to the competitors so that the competitors can match the data with, or match the price with Dollar General. For example, if an say hamburger buns is sold for $1.50 in a retail store near me, if the data scraper got hold of the data, he or she would sell this data to a competitor, so that the competitor also will make their price adjustments based on Dollar General's price, and they would adjust the price to $1.50, something like that. Right. So this poses a larger security risk, particularly in the generative AI models, because at least on the in today's world, when generative AI is not implemented, uh, there is no loss to the company when data scrapers hit, because all the infrastructure where the applications are hosted, it's already paid, and it's only the traffic. There will be you will see just the traffic spike and some data loss, which anyway we cannot avoid. The reason we cannot avoid is our own marketing teams inside Dollar General itself. They also scrape the data for whatever business reasons, right? So you cannot really differentiate between the real data scrapers versus the bad data scrapers. There are some ways to identify, which I'm not going through, but in general, I'm telling this is we open the data scraping. We open this channel for scrapers to scrape the data. It's not entirely kind of, you cannot say that we are completely stopping the data scraping, right? The reason being, as I said, like our own marketing team scrape the data for whatever activities that they want to do, right? So in these scenarios, if generative AI models are implemented, it can quickly burn the model. If they are hitting 2 billion times to the models, it can quickly burn the model and subsequently brings down the functionality behind the model, right? So how do we mitigate that is what I'm going to talk about in the next few slides. As I already explained, like how retail differs from traditional systems is because retail is driven mostly by guest traffic, whereas most of the other systems like banking, all those, they are 100% authenticated users. So you know exactly what kind of traffic is coming to you, whereas in retail, 50% of the time you are blind spotted and you really don't know who are hitting your websites and APIs. Large scale guest and transient user access is another unique uh, unique landscape to the retail which we have to deal with, and open interaction channels like chatbots, feedback, and voice channels are another prone channels for attack. And there are real-time decision models which influences the transactions, like dynamic pricing, inventory adjustments, all that. um, those are prone to attacks. and exposure surface expands when you integrate multimodal agents, like I was explaining before. One agent will pass the data to another agent, subsequently to another agent for whatever operations is required, right? Any questions so far? I'll pause for a few minutes here. If you have any questions on whatever I've explained, feel free to ask. I can answer. Cool. Okay, so what are some of the cyber attack vectors in agentic AI, right? In general, and I've picked up the top vectors that are most prone for retail industry. The first one being data poisoning, wherein the bad actor inserts malicious data to corrupt model training. And the second one being prompt injection, and wherein the bad actor will inject adversarial prompts, manipulating outputs to bypass the controls. And the third one being tool or plugin injection, where they inject a Trojan inside your toolbox, thereby attacking your underlying models. The fourth one being memory poisoning, where they can corrupt your agent's memory or the saved context which you have already trained on those models. And the fifth one being agent hijacking, where they can compromise your agent's runtime or session. And sixth one being model stealing or extraction, where they will try to extract the model that you have already trained, and they'll try to clone um, your brain or whatever that you have trained to the model will become an IP. So if proper security measures are not maintained, they can easily clone the brain and steal your proprietary information. We'll go through each one in detail. So data poisoning, right? We'll talk about data poisoning. So data poisoning is one of the most dangerous attack in retail AI, right? Because it targets the system as its foundation, right? The data that it learns from in retail AI systems, where we continuously ingest massive volumes of customer behavior data, which includes like clicks, user searches, then reviews. By reviews, I mean product reviews, and and some of the transactions that they do on the website, right? So today we track all these in terms of pixels. We use various third-party tools, right? Each tool usually allows a pixel mechanism. There is a pixel SDK that is available to track these user behavior, right? So most of this data comes from anonymous or guest users, which makes it very difficult to trust, right? Attackers usually exploit this openness by injecting like carefully crafted data or poison data, whatever we call it, which appears to be legitimate on paper, but it is designed to influence how your model behaves. And in practical terms, data poisoning like involves injecting malicious data or even a compromised model uh, into the training pipeline, thereby affecting your model performance, right? If we talk about specific retail example, for example, a specific data set, can be poisoned using a specific product name or a SKU pattern. For example, usually there is a SKU pattern when how do I explain? Like whenever we bring the product up in the website or app, usually there is a product hierarchy where it follows specific SKU pattern, right? So when I say product hierarchy, under one product hierarchy, you have multiple SKUs. Each SKU corresponds to one product in the website. So, and we generally follow a SKU pattern to assign the SKU number to the products. So attackers can actually use that SKU pattern to attack specific products and poison the model based on those SKU patterns, and thereby um, it can bypass the fraud thresholds. It can allow unauthorized discounts, or it can also approve suspicious refunds once the model is attacked and compromised, right? Um, how do we mitigate this is one way of mitigating is usually the data poisoning always starts with strong data provenance, meaning exactly where the training data comes from and how much it should be trusted. Retailers must differentiate between high trust signals, such as like completed purchases, verified customer accounts, and supplier data, all these, right? So by weighting and segmenting data sources appropriately, we can actually reduce the influence of malicious inputs or model behavior. And also, we can also do some um, uh, input detection, robust data set curation, and anomaly detection as well to avoid uh, these bad actors to poison your model. So in theory, the key takeaway here is data poisoning is not just a technical risk; it's a direct business risk where it can silently degrade decision quality and thereby undermining customer trust and causes severe financial loss to the company. And the next one, next attack type is prompt injection and adversarial prompts. So prompt injection is something that prompting attacks target AI systems at the interaction layer, the moment where humans, applications, or other systems communicate with the agent, right? In retail, this interaction layer is heavily exposed through customer service chatbots and virtual shopping assistants, which I was mentioning earlier, where user can just update their shopping list and the agent automatically assists the user to check out the product and buy the product. And some internal operation tools where we apply pricing engines to adjust the pricings and inventory, all that. Because these systems are designed to understand the natural language, attackers can actually embed malicious instructions with which again looks like legitimate looking requests, but there are some bad intentions behind these prompt injections to basically attack the model. So prompt injection usually involves like crafting input that overrides or manipulates the agent's system instructions. Instead of directly exploiting the software vulnerabilities, attackers exploit the AI's reasoning process. Um, Thereby, in retail, this could involve like asking chatbot to, for example, asking chatbot to ignore the previous instructions or the training instructions that were given to the model, um, and embedding hidden commands with the long product inquiry. All these are kind of prompt injection attacks. Um, how they can do in retail, if you talk in retail, the specific example for this kind of attack will be they could submit a carefully worded task description, which causes our retail agent to reveal internal context such as API keys, the backend URLs, or the kind of discount logic that we implemented, or we usually we usually use refund thresholds in our organization for a specific product, so they might usually target these refund thresholds to get what kind of logic we are using for refunds, all that. And in a customer service scenario, this could enable unauthorized different refunds or price overrides, or inventory adjustments, all that, right? Um, and how do we mitigate this is mitigating prompt injection basically begins with strict separation between system prompts and user inputs. System instructions must be immutable and protected, while user input should be sanitized to remove attempts to alter the behavior or inject control commands, right? And then even with like strong prompt controllers, right, retailers or companies like us should always assume that some adversarial prompts will always slip through. So that's why least privileged tool access is always critical. AI agents should only be able to perform actions that strictly required for their role, right? We give proper role-based um, we provide specific roles to AI agents, and it should stick to that role of performing to the specific action. And the output filters act as an additional safety layer, preventing sensitive information such as like credentials, internal workflows, or proprietary logic from being exposed. Um, we just add some output filters to prevent these sensitive information leak. Um, so key takeaways on the prompt injection is, again, it's an active and evolving threat in customer-facing retail AI. Effective mitigation is required at all levels to mitigate the prompt injection attacks. Okay, we'll move on to the next slide. The next type of attack is tool or plugin injection. Um, Tool or plugin injection is again a kind of attack with direct operational impact on the retail systems. In general, the way how it looks like is that um, the bad actors will carefully craft inputs that causes the agent to invoke external tools in unintended ways. Rather than like exploiting a software bug, the attacker tries to exploit the agent's reasoning process and the trust in its in the agent's tool set, right? For example, a prompt might be framed as a legitimate operational request, but actually instruct the agent to like export the product data or modify the configurations beneath the API, or execute some commands outside its intended scope, right? These kind of tool injections can very well happen by the bad actors. Retail specific example is a kind of say an agent that is compromised could be tricked into calling an, for example, let's say inventory API, right? It to if the bad actor catches hold of the inventory API, they can trick it to expose real-time stock levels across stores, or invoking a pricing engine logic to apply unauthorized discounts. Say if the company has like given a discounts of 10%, the bad actors uh, can compromise the agent to make look like the discounts are more than what was given, what was set by the retailer, right? These actions can directly result in financial loss, data exposure, and also operational um, disruptions. All of these are executed under appearance of legitimate AI-driven automation. It all looks like real on the paper, but um, but if it is unmonitored, if it is not monitored, there would be a severe financial loss. And how do we control this is, how do we mitigate the tool injection is basically start with at least strict tool whitelisting, where agents should only have access to explicitly approved tools that are necessary for operating uh, the models, right, in their defined role. Like for example, a customer service agent, for instance, should not have access to the infrastructure or any export tools or role-based scopes, right? Anything that was defined behind the infrastructure, they should not have access to. Customer service agent should only act upon what is trained on that agent and should only respond to customer questions, right? By restricting the access to the agents itself, we can mitigate the tool injection. And also beyond access control, like command parameter validation is also critical, where inputs passed to tools must be validated to ensure they match expected formats and certain business rules, right? Um, in retail operations, this is very important because these actions directly affects pricing, promotions, and it also affects the inventory inventories in for a given store. Okay, we'll move to the next slide. Another attack that can happen is memory poisoning. So the way memory poisoning can happen is, right, usually one of the characteristics of the AI systems is memory, which is the ability to retain the context across interactions and basically use the past information to improve the future decisions, right? And in retail, this memory enables features like customer personalization, um, and continuity in customer conversations, and learning from the previous purchases, and give the product recommendations based on the previous purchases. All that is driven by agentic AI systems, which stores the context and memory. So memory poisoning usually occurs when attackers repeatedly feed false or misleading information into agents' memory, where each interaction may appear harmless, but if you look at collectively, they can bias the agent's long-term behavior, because memory updates often happens automatically, and as you know, it often happens incrementally. um, Unlike prompt injection, the damage here is delayed and cumulative. Over the period of time, you can inject wrong prompts and affect the memory, right? So in a retail scenario, for example, attackers could repeatedly introduce incorrect information about, like, say, um, discount eligibility or product availability, and also about return policies, inventory adjustments, dynamic pricing, all that. Um, Over the time, these agents that we train begins to treat these uh, false statements which were injected by by the attackers. They think that it is a trusted knowledge, and it can very well embed that to the agents, which will lead to incorrect customer guidance, inappropriate prices, inappropriate inventory, all that. Right. So how we can mitigate is mitigating memory poisoning basically starts with governance. Retail AI systems must not treat all memory equally. Persistent memory should be created, source tagged, and assigned confidence levels. So specifically, information originating from anonymous users should not be stored as long-term memory because, as I said, like 50% of the user traffic is mostly driven by guest users. So anyway, for guest users in most of the retail applications, coupons and cashbacks are available. If you have observed, coupons and cashbacks and all the discounts are available only for authenticated users. Guest users usually like just log in if they want to quickly buy without creating a account. They can just log in as a guest and buy the products, right? So what we are suggesting here is for the guest users, do not persist the memory, since anyway they are just one-time buyers. We consider them as one-time buyers or quick buyers, which mostly makes purchases below $10 to $15, at least $10 general. I'm not sure in other retailers what that number is, but the number is significantly lower. The purchase price is significantly lower. So do not allow your models to start storing the memory for the guest users. That way, you're mitigating at least 50% of the risk. And also implement some validation mechanisms like before we commit the information to long-term memory, make sure like we cross-check this data against authoritative sources, such as like you maintain a policy database or product catalogs, for example. Just cross-check this data with those sources and make sure they are valid before persisting that into the memory. Right. So the key takeaway is that memory always turns AI agents from reactive tools into learning systems. So, and that learning systems must be governed without applying controls. The memory can be poisoned quickly, and it quietly degrades your retail AI performance over the period of time, and subsequently, sometimes it drives the financial loss as well to the company. And the next one is agent hijacking, which represents the AI security, where the security converges directly with traditional cyber security. In this attack, adversaries do not merely influence AI behavior; they take the full control of the agent itself. In retail environments, AI agents often operate as trusted digital workers, or whatever you call digital workers or digital helpers. And sometimes they hold credentials, they access APIs to fetch whatever information that is required, all that. Agent hijacking typically occurs through stolen credentials, compromised sessions, or insecure runtime environments. This might involve leaked API keys, exposed service accounts, or insufficient isolation between agent components, all that. But once this is compromised, the attacker can actually issue commands to the agents as if they were a legitimate system or operator, right? Because the action comes from a trusted identity because they have stolen the actual identity itself. So the the request actually comes from the real authenticated credentials, and they might bypass your traditional security alerts as well. So in retail scenario, a hijacked agent could access our order management systems, or modify the pricing rules, spin up unauthorized cloud resources, whatnot, right? They can have once they got hold of to the agents, they can technically do unlimited things to get hold of the agents. Um, Sometimes they can also get control of the full supply chain that is behind the scenes, um, right from the identification of the product to procurement, then merchandising, then bringing up to all the way to the app and web. Um, they can get hold of the entire supply chain logic, and they can attack, right? So how can we mitigate this is basically use the strong secrets management so that all your passwords and user IDs are stored securely in the secret manager, and only give access to specific people who are responsible to managing those secrets. And we must ensure that agent credentials are stored securely, rotated frequently, and never hard coded inside the agents. Um, like maybe make it short lived and based on a TLS limit, like maintain a TLS limit and rotate those passwords frequently so that the password does not remain constant. Um, and also, continuous session monitoring and anomaly detection are also essential, so that you can mitigate the risks very early. So we should continuously monitor the agent behavior for check for any unusual access patterns or unexpected tool usage or any activity outside normal business hours. Usually most of the uh, purchases happen in the day, right? In USA, at least 8 to evening 9. If we see any abnormal behavior in the non-business hours, the midnights, then it has to be monitored and then take appropriate actions. So another attack that might happen is the model stealing or extraction. Model stealing is basically stealing the intelligence behind the agents that we have trained over the period of time, where the attackers can steal the knowledge that was trained to the model. Like over the period of time, company might have trained the models on customer behavior, and also the pricing strategies, like what kind of strategies we are following in pricing the products, and also recommendation logic or fraud detection, whatnot. They can once they steal the model, they can get hold of all the proprietary information that the company has trained the models over the period of time. Um, in retail context, like an attacker could probe a recommendation engine to infer how pricing, promotions, or personalization logic works. Right? They can the way they do it is they carefully plan their inputs, and then they just observe the outputs to clone the model over the period of time on their side. On paper, it looks like they are all genuine requests or legitimate requests, but um, but they're intelligently stealing the data behind the scenes and then building or cloning the model uh, on the other side, right? So how can we mitigate this is for authenticated APIs, always implement API rate limiting to prevent high frequency probing. And also we should always continue monitoring usage patterns to detect systematic input variation that suggests reverse engineering attempts. There are ways to uh, do the there are ways to find out how are the patterns to find out how the systematic how the bot or attacker is systematically using their inputs to steal the memory. And also behavioral analytics can help distinguish legitimate browsing behavior versus the malicious intention of using the prompts to steal the memory. And other one of the other way is also watermarking the AI outputs is also an effective technique for tracing proprietary content when it appears outside authorized environments. Um, like also response obfuscation, such as adding controlled randomness to the model output, can also help mitigate some of the risks of copying the model. So, what are the business consequences of AI model compromises? Right, the first and major will be the financial impact, wherein compromised models will have large financial impacts on the companies. So if we are using inbuilt RAG system, if company has built its own RAG system, then the RAG or the agentic infrastructure sits inside the company. That's once the company has invested money to build the system, that's the only upfront cost for the system. But if company chooses to go with API route and uses GPT APIs to perform these transactions, then as I said in the beginning, like guest user traffic drives larger costs to the system because generative AI APIs are charged per token or per request. If 2 billion requests is per day of traffic is driving, and thereby they're making a calls to generative AI APIs, that would have a severe financial loss to the company if those are not recognized and mitigated. So today, what we do, if before the generative AI models were implemented, uh, we normally allow this data scraping activity throughout the day. Only when we think that it is disrupting our regular customer traffic, we go and we have alerts in place, dynamic trace and alerts in place to check for the traffic patterns, and we normally huddle in call with our security team, and at the API gateway side, we identify those bad actors and we try to block the traffic. The reason why we do it manually, as I said earlier, is you cannot just assume that all guest traffic is a data scraping traffic. And also within the data scraping traffic, there are legitimate companies who does data scraping. Like for example, um, we we list our products in Google also, right? The way we list is we send a feed to Google, and Google actually uses that feed to scrape our traffic, and then they subsequently index the pages in Google. So right, that's a legitimate use case, and they use that using guest APIs. They don't use authenticated requests, right? That is a legitimate traffic that we use. right? That's one use case. And another use case is our own marketing teams. They also use data scraping to basically get the prices, and they adjust the prices. There is a whole algorithm on how to adjust the pricings, dynamic pricing, all that. But what I'm saying is some of the traffic is genuine traffic and some of the traffic is data scraping traffic. So the way we identify is we look into our API gateway and analyze all the IPs. Usually these bad actors follows, most of the time they follow specific pattern. So by looking at it, you can identify the pattern and then stop the traffic for those bad actors, right? And and the irony is that these bad actors always comes from cloud environments like Google, Microsoft, or Adobe, right? They look like a genuine traffic, but behind the scenes, the IPs and ASNs is where we need to identify the pattern and then stop the traffic. You cannot just stop the traffic directly on and say, okay, this traffic is coming from GCP, let's go and block the entire GCP. We cannot do that. The reason being some of the uh, because we might be using vendors, for example, our payment gateway, right? The payment gateway might have been from a genuine vendor which is hosted in GCP. The moment you stop traffic from GCP, it would stop the payment system as well. So that's why there is always a manual intervention that is required. So whenever we see these patterns, we always huddle into a call and then identify the patterns and stop the traffic, right? So in generative AI systems, we are still learning how to do that because you cannot stop the traffic entirely. We should definitely find some alternatives and find an algorithm, to find a pattern, anomalies, or whatever, right? Or so come up with something to stop that kind of traffic. And yeah, for the consequences, there will be a severe financial loss in case of uh, bad actors or attackers try to attack your agent. And then there is an operational system downtimes, like frequent attacks to the system will cause your models to burn. In the case where I said, like, when bulk uh, data scraping happens, they can actually hit your agents or agentic models in the backend, and continuous inputs may burn the model and may bring the entire agent down, thereby affecting the entire functionality of that agent. And we will also lose customer trust because if this happens continuously, customers will lose trust on the website. Uh, Maybe the website might also mislead the recommendations, all that, thereby driving customers to not come to the website for the purchase, which indirectly affects the revenue of the company. Yes, some of the research implications and future directions. There is a need for standardized AI security benchmarks for generative AI, particularly for retail. There are already benchmarks for authenticated environments, but for retail, it's a different use case. So they definitely need some research on that area. And integration of explainability plus security frameworks is another research area. Also, cross-domain threat intelligence sharing. What I mean by this is if you are using um, vendors inside the app and web, usually we have more than 50 different vendors that we use services for. So whenever even most of the vendors are now moving to use generative AI models. Whenever they see the threat, if they can share it with the partnering company immediately, that would actually help companies to find out those patterns that are shared and then mitigate the risk. And then anomaly detection and sandbox testing environments is something that we need to research on and check how those work. So in conclusion, retail AI's openness makes it a prime target for bad actors or attackers to exploit the weaknesses in the agents and thereby corrupting the agents, which again drives financial losses to the company. These kind of attacks degrade trust and operational continuity, thereby driving away customers from purchasing the products from open web. Build like resilient, transparent and auditable agentic AI systems, so we mitigate most of the risks that I mentioned above. And security must evolve continuously alongside AI. In the, like I said, in generative AI world, it's still new and we are still learning. So as and when we learn, it should continuously evolve, and security should be considered as a major uh, implementation alongside of generative AI application. Yeah, that's all I have for today. If you have any questions, please feel free to ask them.
Thank you, Suresh.
Thanks, boss. Yeah, please feel free to connect me at LinkedIn. I can connect or collaborate for whatever we can do in future. We all as a community, like I'm also in the Buzz's WhatsApp channel. We can always collaborate for ideas or solution architectures or anything like that.
We had one question in the chat, so maybe from Daniel. Quick question on engineering workflows. How widely adopted is AI coding assistance across teams today? Is usage of tools like Cursor, Cloud, Code, or similar fairly universal, or is AI proficiency still a gap the org is actively working through with a team this large? Yeah, you're muted, Suresh.
Oh, sorry. Can you hear me?
Yeah.
Yeah. Thank you. Yeah. That's a great question. Yeah, adoption is rapid, but not yet universal, right? Tools like GitHub, Copilot, Claude, and similar have seen fast adoption, but especially for like generating boilerplate code, writing tests, refactoring, all that. But adoption, I would say, is not truly universal yet. And for most of the teams that are inside our company, at least, a proficiency is still considered as a gap, right? We are still trying to train people, like near level, mid-level engineers, to bring them up to speed for this knowledge.
Thank you. We already 4 minutes over. So thank you so much, all, and we will see you in the next session.
Thank you very much.
Thank you.